Okay, ladies and gentlemen, we are now looking at section 1.2 notes. We're looking at dot plots, stem plots, descriptions, things of that nature. So, describing a distribution, don't forget your SOCs is kind of the acronym I use for this, or SOCVA if you use the V here instead of the S, and I'll go through the differences between the two. Alright, so the first S is shape. So when we're describing a distribution, we'll first use shape as a way of describing it. You'll use language such as normal, skewed left or right, bimodal, unimodal, and there's probably some that I'm forgetting, so I'll put etc. If you're like, I've never heard of bimodal or unimodal before, that's just referring to how many peaks the graph has. So at this point, you've likely have seen some distributions from me in class, and so when you have a distribution, it can have one peak or two peaks to it. So if it kind of goes up, back down, and back up again, that would be bimodal. It has two peaks. If it's something that has more than two peaks, extremely unlikely, you can just say that it has three peaks. If you're like, I'm never going to remember the definition of those words, that's fine. You don't have to use super statsy language to do well on the AP Stats exam. You can just say this graphical display has a shape with one peak or two peaks, and that's perfectly fine. So don't feel like you have to use this language if you're afraid you're going to use it wrong. The O in our acronym of SOCVA or SOCs stands for outliers. We ask ourselves the question, are there any outliers? Where? The C stands for center. Where is the center? Are we using the mean or the median to describe the center? And if you're like, I kind of remember those, but not really, know that that's okay. We'll be defining them here in just a moment. And then the last, the S or V, depending on which acronym you like better, really, stands for shape or variability. Or not shape, I'm sorry, because we already did shape. It stands for spread or variability. So questions to ask ourselves here is, how spread out is the data? Things like, what is the range, standard deviation, or interquartile range? So standard deviation I shorthand as SD, interquartile range I shorthand as IQR. We'll be defining these further down in the notes, so don't be alarmed if those seem really new to you. Okay, we'll be going through those. So when we're describing a distribution, we use this acronym because the AP exam is wanting you to describe it to their standards. And their standards is that you talk about the distribution shape, outliers, center, or variability, or the spread of the data. Okay. First thing we're going to do is we're going to describe the three ways you could describe shape. Okay. So this first box here is to look at the ways you could describe the shape of a distribution. I know I used the word normal in my definition above, but we're not going to be using the word normal until we get into chapter 4, I do believe it is, maybe chapter 2. But this chapter 1, we're not using the word normal. We're not going to define what it is yet. That's a whole chapter in and of itself, okay? So you might be like, oh, I remember normal distributions from Algebra 2. We'll get to them, but this is not it yet, okay? So the way we describe shape, symmetric, skewed right, skewed left. Symmetric is if the right and left of the graph are approximately mirror images. Skewed to the right or right skewed. The right side is longer than the left. I'm going to draw you pictures of each of these as well. Skewed to the left or left skewed. Left side is longer than the right. Symmetric is the easy one. We've been dealing with the word symmetrical forever. Now, the beautiful thing about stats is we use this word approximately all the time, meaning it doesn't have to be perfect, and that's okay. This graph is approximately symmetrical on the left and right side. Are those dots exact? No. But that's okay. They don't have to be. Then we have right skewed. Now, to remember right skewed and left skewed, just remember which is your right foot and which is your left foot. Because the way that your right foot is shaped with your toes, if your left foot is shaped with your toes, is identical to right skewed and left skewed. So, that's a fun little tidbit trick for you. So, right skewed would look something like that. And left skewed would be something like that. Really, you want to get the general shape of, right skewed, it's drifting to the right, so this would be like your pinky toe, and that's your big toe. Left skewed is going to the left, so this would be like the pinky toe on your left foot, and that's your big toe. All right, so this is shape.